are here for our wonderful weekly TWIS podcast broadcast. Thank you for joining us. Everyone, coasts? Yes, co-hosts are now coasts. Coasts, please say hello. Let's check those microphones.
Heyo!
Well, hello there.
It all sounds good to me. So I believe we are ready to begin this weekly assemblage. We're all together again. Yay! And we're going to talk all about science. And some things are going to get edited out of this live video broadcast, which is going live on YouTube, Twitch, and Facebook. And then it'll be a podcast. And that'll be the edited version, but not too much editing, hopefully, because we always try and keep it to a tight 90. And I think that's all I really need to say before we actually begin what's going on here. So without any further ado, let us ado. I'm trying to get my solo. There's my solo layout. Kiki solo. Are we ready? Yes, we are ready. To begin in 3, 2, this is TWIS. This Week in Science, episode number 921, recorded on Wednesday, April 12th, 2023. There's bacteria in your eye. It's true. I'm Dr. Kiki, and tonight we will fill your head with wolves, monkeys, and robots. But first...
Disclaimer. There is a constant effort underway to understand everything. Not everyone knows this, and not everyone cares. Most humans do not question the world around them. They wake up, go to work, come home, eat a quick meal, yell at the television, and go to bed. Human reality tends towards fantasy. Identity wrapped up in tribes, teams, and the products that they use. People get angry at products they identify with if the products are inclusive to other tribes, infringing on their identity, their fantasy, and their personal brand. Such a sad existence. The brand managers and ad copywriters should be proud. Their work has had a lasting impact. There is another world taking place where people are using their minds to unlock every mystery, to observe and record every detail, to understand every interaction in a complex and intricate reality. A world where the brain is not branded by logos, where the mind is free to see and explore, to think, question, and go beyond. A world where we gather together to talk about all of the interesting things we have discovered this week in science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. Woo woo! We are back again. Blair, thank you so much for taking over with all your animals last week.
Oh, you got it. It was extra fun. It was crazy.
It was wild and crazy.
Yeah.
And yeah, did you hire us a new co-host? Is that what happened?
Oh, I did. He's just he's the gopher now. He just brought me some water, so you know he's demoted back down to kind of behind the scenes help. But I really appreciate Brian stepping in last week and doing an amazing job. helping me out.
Yeah,
Fantastic.
it was fantastic. I hope if people out there have not yet seen or heard the episode that they go check out last week's episode. But it is time here now for this week's episode, and we're all here ready to talk about the science that we have brought. I have eyeball evolution, fancy glasses. Yeah, they're going to help you do something. Brain aging, that is happening, and monkey models. What do you have, Justin?
I have got the dire wolf of Canada, a probiotic aging story within a story. An urgent announcement from This Week in Science, dietary edition, and tell me it's not a ritualistic ceremony. Look at old ancient Europeans.
Oh, that's a good segment. We like to we'll be bringing it back more and more. Is it? Is it not? Let's talk about that. And Blair, what is in the
Yes.
animal corner? We're putting you back in the corner again.
Yeah, that's fine. It's where it belongs. I brought some tiger personalities and some wet birds. But before that, I also just was compelled to talk about menthol and Alexa and Roomba this week. So short stories on those items. Not animal related, still sparked my interest.
It's animal related.
I immediately started thinking like robots smoking menthols.
Yes, they're two separate stories, although
Okay.
who knows, maybe
We
one
do.
day.
We do know that Blair is a fan of Futurama, so I mean, I don't know,
Yes.
it's very possible
Yeah.
that was in there in an episode. Okay, it's time for us now to jump on in to the science. But first, oh wait, I do want to remind you that if you haven't subscribed to the podcast yet, you should do that. That's right. It's a podcast. It's also a broadcast. We broadcast live weekly, Wednesdays, 8 p.m. Pacific time on YouTube, Twitch, and Facebook. And we are podcasting just about everywhere there are podcasts to be found. Look for This Week in Science. We are at TWIS Science on the Instagram, on the Twitch, and we are also on Universidon and also the Twitter. We're there as at TWIS Science. But, go to twis.org if you need any more information. You can find all sorts of things at our website. Now it's time for the science. Let's start with your eyeballs. Where'd they come from? How did...
A head?
Well, they're in our heads, but where
okay.
did they come from? How did we get the vertebrate eye? How did we get these camera-like eyeballs with their many molecular sequences that lead to the changing of light energy into electrochemical energy that allows us to see? How did we get there? Right?
Well, I can only go back as far as fish.
As far as fish, but there were some vertebrate fish,
Then
right?
it's blurry.
Yeah, fish are vertebrates.
Yeah. There are definitely vertebrate fish in there, but researchers have been looking at all of the molecules in the eye and they're like, this is a complex thing. And if you know people who like to argue against the idea of evolution leading to how we got here and instead try to discuss the idea of intelligent design, there is often the idea brought up of the human eye.
Yeah.
The vertebrate eye is so complex that there's no way that it evolved on its own.
You know why that falls apart immediately? Cephalopods. They also have a camera-like eye. It has evolved twice. It is convergent evolution, therefore certainly possible.
Certainly possible, but their camera-like eye does work.
That and the threshold, just the threshold for what's too complicated.
Yes.
For the folks that are making those arguments, usually includes a lot more than just the eye.
There's usually a lot more in there, but the eye is
everything.
Yeah, the eye is one of the
science
things.
Is in that category.
So, the vertebrate eye, it is pretty complicated. There are lots of mechanical steps, lots of little tiny molecules in the eye that go flip, 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 and they have to go up one place and change structure, and then they have to be brought back to another place to go back to their original structure. So the light comes in, and the molecules go, bah! And they change their structure, and then something has to put them back so that they can go blah again, and so that the whole thing can happen. Well, researchers have been trying to figure out, okay, where did all of these different molecules come from? And many of them we could see have been part of eye evolution for a very, very, very long time. But what is the thing that makes the vertebrate eye the vertebrate eye? And so researchers at the UC San Diego have been trying to find parts of these molecular sequences that are special. And they looked at one particular molecule called interphotoreceptor retinoid binding protein. They looked at the genes for this in the human eye. They found that there were like 4 copies of it in the human vertebrate eye and other vertebrates. And they traced it back, and they discovered that there were some bacteria that had this gene, this protein, before us. And the interesting thing about this is that they suggest that this bacterial gene came to be in the vertebrate eye through a jump, horizontal gene transfer from bacteria to vertebrates. And it was the jump of this gene that allowed suddenly the rhodopsin, the retinal pigments, the rhodopsins, to change structure when they get excited, and then the interphotoreceptor, blah blah blah, IRBP, it would take the pigment and put it back in the structure that it's supposed to be back in. So this is a very important protein, and they couldn't figure out where it came from. It just suddenly appeared in the vertebrate eye, and the genetic story that they are telling is that it came from horizontal gene transfer for bacteria. Now, in bacteria, in the genomes of the bacteria that they've been looking at, it only appears usually once. And like I said, there are 4 copies of it in the vertebrate system. And so what they're guessing it happened is that it maybe had a different function in the bacterial cell, and then transferred over, and then wasn't really doing anything, and maybe it got copied again, and it got copied again, and copied, and eventually it started leading to this function. And the molecule, the IRBP, it became a thing through evolution. And it is suggested, these researchers think that, maybe it, when it moved into vertebrates, that it became important, and this is what it did in the vertebrate eye. Other researchers say, hey, that's nice. Cool that you found this bacterial gene and protein. That's cool. But like, it could have been a total accident. And maybe it just made the eye work better. Totally accidental, right? Just, we copied it and suddenly it has a function that didn't do bad. So it worked.
You got your bacteria in my eyeball. You got your eyeball in my bacteria.
Yes. Yeah. Yeah. So these researchers, they dug into IRBP and all these domains and the bacterial family trees. They did a bunch of phylogenies, and they really determined that this is common among all vertebrates, and that's it. It is not so like we have to look at the octopus eye, which you say the cephalopod still has camera vision, but do they have this protein, and does it work that way? Right. So far, the evidence does not suggest that it does or would.
Wow.
That's awesome. I can't wait to find out more.
Yeah. So anyway, our eyes, vertebrates, we're special because we got a bacteria in our eye.
Heck yeah.
Yeah, got some bacteria.
That's awesome.
Yeah. Tell me a story, Justin.
Oh, where are we starting here? So this is, I guess I'm starting with this one. This is one of these kinds of stories that we've brought quite a bit of, especially during the pandemic. We have researchers who are sitting around twiddling their thumbs in Canada, wondering, what should our next project be? And then they realize, hey, there's a whole bunch of stuff in drawers that was collected a long time ago that nobody's identified in a paper. And so they went digging through. About a year ago, they discovered in this one collection, this medicine hat dig site, that somebody had collected this Smilodon, this saber-toothed cat. It is the only one that had been found in Canada.
Huh.
And so, okay, well, hey, they wrote a paper about it, identified it, and then, it was like, hey, that was fun. Sitting around, twiddling thumbs again. And I said, yeah, there's other stuff in it. Yeah. Let's go back into that same box, those boxes from that same site. And they found a Canadian direwolf. The direwolf is an extinct cousin to the wolf, not an ancestor. bigger than the modern day gray wolf, and has tendency to overlap in territories with saber-toothed cats. You find them in North America, South America. They've even been found in China. So they went through and they did the fossils weren't in great condition. They're it's possible that when they were first discovered, they were identified as direwolf, but no official paper was ever written about it. Much like the Smilodon, we think that's what we've got there, but we're not gonna publish on it. What's interesting, I thought, is that in the first study they just went and published on it, and they found it. In this study, they found the original author, and he's also the original person to describe it unofficially in a report, and included them on the study. So they got to finally publish on this. But after a thorough analysis, it firmly fell within the range of direwolf, putting it hundreds of miles north of where the any other direwolf had been found. It also points out that I guess 3 years ago now, there was northern China had discovered direwolves there, which also then, and this is about 45,000 year old fossil, which also suggests a time when they were able to travel back and forth, because this is also within this fossil find in the site. There are camels, bison, horses. There's all sorts of things that we're not used to seeing really far north in Canada. This is south of the Saskatchewan River, which, for those of you not familiar with Canada, you got some of the cities you might recognize on the East Coast, Quebec. And you got the West Coast. You got Vancouver. People have heard of that. And then there's the whole middle of Canada, which so it's not as far north as Manitoba. But since nobody knows where Manitoba is, it just kind of defies the purpose of the description.
It's up there, basically.
It's somewhere in the middle
Yeah.
of a big country that in an area where there's more moose than people.
Well, that sounds like an attractive place for a direwolf to go.
Yeah.
Lots of food.
Yeah, but I love the timing of it too, because it suggests that maybe there was a corridor, and maybe they were following food, mammoths, and other creatures that were going back and forth, and maybe 40,000 years ago to 25,000 years ago or so.
There was a window of time.
There was the
45,000 years ago. There's a window of time when we're not in ice age. Like, we had a little mini one before that, and then this is before the really big one sets in, or as it's growing. And so we also know that wild horses had been traveling back and forth. And it's interesting that there was so much turnover at that last ice age, where a lot of things didn't make it. That last ice age,
like the
really
direwolves,
changed quite a bit.
mammoths.
It's also, there's part of this that makes me wonder why this wasn't published. Because this is like the first Smilodon, the first direwolf. And, we'll put it in a report, but we're not going to publish. This is also, I think, around the time when the earliest evidence of humans and Beringia were being found, to be about 20,000 years ago.
Yep.
And that guy did publish, and that guy got ridiculed. Jean-Marc, I'm going to mess up his name because I'm doing it off the... So maybe they're like, let's not be first.
Right.
I don't know.
There comes a certain point, if you've done it before and you've been through it, you're like, maybe I'll just keep it to myself until there's more evidence, until somebody else comes up with something. But yeah, just the size of the fossils that they've found, they're so cool. Yeah. And that's neat. What a wonderful find.
We may have crossed paths. There was my point. The first people coming into the Americas, if they were beaten the Ice Age, which is what kind of now a more prevailing theory is, some of them might have gotten here before the Ice Age kicked in completely. That's when this fella was traveling around up there too.
Oh, would have loved to see ancient man battling the dire wolf.
No,
or
not battling. No,
or the
running.
leftover scraps of mammoth.
Trying desperately to avoid.
Yeah.
No fighting.
Yes, no fighting, no fight. We don't
Another
like
dire
fighting.
wolf.
Let's not-
Domesticating the direwolf?
yeah, possibly.
Losing fingers in the process?
Do tell.
Yes.
We aren't domesticating, but we do like to have a little bit of fresh mint flavor every once in a while.
Oh, yes.
Tell me what's up with
Particularly,
mint.
yeah, if you vape or smoke. This is from the University of Pittsburgh, and they found that adding mint flavor to e-cigarette liquids produce more vapor particles and are associated with worse lung function in those who smoke. Mint and menthol, despite kind of the push to reduce flavored e-cigarettes and vape options in the United States, they're still really popular. There's about 2.5 million youth who reported smoking e-cigarettes in 2022 alone. And so these flavored vaping situations still persist, and it turns out that the mint/menthol flavor is actually really bad for you. Before they went with kind of mouse or human studies, they were actually able to make a robotic system that mimics the mechanics of human breathing and vaping. So they were able to pump different kind of vapors into that. And they showed that commercially available e-cigarette liquids that contained menthol generated a greater number of toxic microparticles, compared to menthol-free. And that when menthol vapors were taken in, there were shallower breaths, there was poorer lung function compared to non-menthol smokers. That was regardless of age, gender, race, pack years of smoking, or the use of nicotine or cannabis-containing vaping products. So the long and short of it is, smoking's bad for you. Vaping is not much better. Mint and menthol, really bad. So stay away from that stuff.
But menthol has always been considered bad, right? Like
Right. I think
we've
the
heard about
problem is-
menthol cigarettes. They're like, ooh, menthol cigarettes. They sell them to get more people to smoke cigarettes, but then those are really bad for you. And why would menthol vaping be any better?
Right. I think menthol was really popular in like the 80s and 90s, and then they kind of they put out this information and people stopped using it, but now it's inching back in because of flavored e-cigarettes and vape pens. And so part of what creates the different flavors is menthol. And so it's bringing menthol back into the fold of the smoking conversation, which is a huge bummer, but it's an important time to remind everybody that menthol's really bad for you.
Yeah. I mean,
I feel like this is on the borderline of if you're gonna smoke crack, don't use a tinfoil pipe, because that one will just don't smoke. What is wrong with people?
Yeah, that is definitely the first step. Don't smoke. Yeah.
Well, and I think part of this is that vaping was kind of brought to the table as this miraculous
alternative.
And the more we learn about it, the worse it actually is. It's not this miracle alternative that is infinitely better than cigarettes. There's all sorts of these other problems, not to mention the fact that the marketing of this better alternative was actually a backdoor to be able to market to children again. So that's a whole nother issue because of the flavors.
Teens.
But
youngs.
You can say that the unicorn flavored vape pen is for teens, but it might actually be for kids younger than that. I'm just saying. Regardless.
Wait a second.
Yeah.
I didn't know there was such a thing.
Oh, if you look at vape flavors, they are all over, like
unicorn,
sparkle pink, and like they do all sorts of crazy things to come up with flavors that are appealing to children. That is what they do.
That's nefarious.
So yeah, but stay away from the mint. That's all I'm saying.
Bad. It's bad for the cells in the lungs themselves, right? It's not just not just the compound that's used for the smoke. It's the mint also that's bad. Yeah. Thanks. Well, I won't be doing that anytime soon.
Good.
Thanks. And I hope you don't either. Something that is an interesting question is, how do babies grow in the bellies of, in the uterus? How do they grow?
It's too complicated, therefore religion.
Right. Well, that does come into play in this study that we're going to discuss right now.
Yeah, I do
But
think
not-
it has to do with sucking the lice essence out of the mother. I do think that's part of it.
You may be currently slightly biased, Blair. I wouldn't be one to say. So in this particular study that was published in Cell Stem Cell, researchers were trying to figure out a new way to be able to really look at the developmental gestational process of the embryo. So the blastocyst stage to the embryonic stage. Now, with humans, it's fraught with a lot of ethical issues. So stem cells, we originally had embryonic stem cells. And if you've been around a while, you remember that there was a big hubbub about whether or not embryonic stem cells were going to be allowed to be used in research. And there were 60 stem cell lines that were okayed by then President George Bush and Congress. And the rest of them, it was like, nope, we can't use any more of those embryonic human embryonic cells. No more, because we can't take those cells, because that is fraught with issues with ethics related to the some religious parts of the religious community and others as well. So then people said, oh, but pluripotent stem cells, if we can train skin cells or hair cells or whatever, if we can train them to going back to their baby state, maybe then that'll let us know what's going on. But we found out that there are differences, essential differences between embryonic stem cells and pluripotent stem cells that have been told to go back to that embryonic light state. They're not exactly the same, and they don't progress in the same way. So there are different molecular signaling cascades that are in play. There are different cellular factors that are in play in these cells during the blastoid blastocyst early gestational part of the process. Now, so we can't go into people and be like, hey, how's your baby doing? Because that would interrupt the process. You can't use the embryonic stem cells. The pluripotent stem cells are okay, but they're not doing great. And there's only so far that we can go looking at mice and rats who are not really related to people that closely. Pretty closely, but there are lots of differences. So these researchers said, hey, primates, let's see what we can do about primates. And in this study, they presented their work in getting macaque monkeys, Cynomolgus monkeys, and using their embryonic stem cells to create blastoids, which is the very early ball cluster of the embryo, when you've had the fertilized egg that has split and split and split, and you suddenly have 8 cells instead of just a single cell. That's where you have your blastoid. Now, the blastoid with these embryonic stem cells, they followed it. They're like, oh, can we look at it in a dish? Look at it go. They're growing. They're doing what they're supposed to do. Woo, woo, go, blastoid embryos, go. Grow, grow, grow. And that was very exciting. And then they were like, okay, now we need to take a look at these blastoids in vivo in an IVF situation. So they transplanted these blastoids into mother monkeys to see what would happen. And lo and behold, all of the hormones were just right in the macaque's uterus, and the blood of the mother was spouting off all the right hormones. The blastoids progressed to the phase that's called gastrulation, which is where they start to create a little dent in them. They want to turn into a little donut, basically. So the blastocyst, they followed it to the gastrula. And so this was very exciting because they showed that they could get to a previously not documented stage of the gestational development, and they did that. It implanted these blastoids implanted in the primate uterus. Everything was working just great, and the only reason they didn't make little macaque babies was because their protocol didn't ask for that, and they just wanted to know if it was going to work. So what they've said, in effect, is, look at what we've done. We have created a new model system that gets around a lot of the ethical quandaries related to human embryonic stem cells and allows us a new model to be able to understand gestational development that we have never been able to really see before. So,
Nice.
yes.
Cool.
Go researchers, go. And I find it exciting that and I'm sure somebody's done it before, implanting monkeys, IVF implanting monkeys, but not with the research focus. I find it interesting that at this time, after, we haven't really talked about embryonic stem cells for a very long time. They've kind of fallen off the fad, right? It's all pluripotents. But now we've got organoids, but organoids only go so far. Mm-hmm. So there has to be a middle ground. And
macaques are a lot closer to us than mice. So that's an excellent test model. Absolutely.
It is. I mean, there are still going to be ethical issues. Animal research, there are still issues, but it is not as fraught as the completely human situation. So yeah, maybe we'll learn more about how babies are made in the belly.
Yeah, let's see. When was this ban? It was about 20 years ago or more. Yeah. So just put the research off track by 20 years.
20 years.
That's all. No big deal.
Yeah, no big deal at all. Yeah.
Back on track. Love it.
We're all on track. We're on track to age gracefully. Yeah, Justin?
Oh. This is... Yeah, well, let's see. So this is actually a very interesting study by Chinese researchers. Are work for or associated with this same probiotic company in some way. They studied. We talk quite a bit about the microbiota connection to health these days, understanding how the gut microbes influence the brain and the metabolic systems. So they decided to look at some of the world's healthiest people who were centenarians, people over 100 years old, and study their microbiome up close. So they went to a region in China that is known for having exceptionally old people. And researchers studied the microbiome of 297 people who were from between the ages of 100 and 117 years old, and compared them with different groupings of people from the 20s and 40s, the 50s and 60s. They had these 5 different groups, and they looked at their microbiomes, and they found that the overall structure, the evenness of distribution and diversity, was most similar with the centenarians and the young adults in the ages 20 to 44 years.
Why does that not surprise me? Like, so much of our, go drink the blood of the young people. Like, I mean, if you're aging that well and you haven't gotten into your senescent phase, you're gonna be healthier all around, right? This is interesting. Okay.
Yeah. So this is in the Guangxi province where these folks come from, and they're renowned. They had the oldest person in the world at one point, possibly the oldest person who's ever lived, at 127 years old.
Wow.
Now, officially, they're not the oldest person in the world.
Officially.
Guinness Book of World Records went to go and verify oldest person in the world.
And they were dead by the time they got there?
Yeah. No, actually, I think this is when the person was 125, because that was the current record is, I think, 122, maybe 123.
Did it predate birth certificates?
So yeah, that birth certificates. This is a very rural farming community area of China, and birth certificates didn't show up till 1949. And in fact, most people didn't get IDs for decades after that. And in this case, had gotten an ID at some point, but that was the only one. It didn't get updated at any point. So it was this old faded. And it was also kind of interesting because the woman had given birth to her son at the age of, must have been 61.
No.
Yeah. So which was not even the story at the time, which would have been a big story.
It would have been. I just want everyone, while you're just for a quick pause, I just would like all the podcast listeners to imagine Blair's round saucer eyes at the concept of being pregnant at 61. Anyway.
So there are cultural differences between East and West. In China, there is a higher status for people of older age. And less of an obsession, a focus on youth. So you have everybody in this study, in fact, current study, over the age of 72 would have had to have self-identified, self-reported their age at some point when an ID came about. When somebody came down and was like, oh, we're going to give everybody an ID of some form. That could have been in the 70s. That could have been in the 80s. They could have been, 30, 40, 50, who knows. And to keep this focus off of China for a second, in going back and doing ancestry research, I discovered that one of my grandmothers, between the census, which would take place every 10 years, would only age 8 to 7 years.
Right.
If she was 25 in one census, she was 32 in the next, and then only turned 40 the next time they came around another 10
My
years
grandmother,
later.
I think she was about 70 when she started counting backwards. So every birthday after, she got younger.
So another thing is, I don't know if anybody had noticed, currently the oldest person on the planet is 116. They did a study on aging where they had somebody who reported being 117 years old, and that was not the focus of the story or their study. The oldest person in the world wandered into a study on aging. Nobody mentions it. So part of this is a problem. Part of this is just sort of a China problem, because China also has a good amount of mythology built up around people who work in these farming communities area, who, work from morning to night and get good night's sleep, and that's how they live a long life. There's another problem with this study I found, which is that everybody working on this study is connected to a probiotic company, which also creates a detection system for detecting what your microbiome is. And while at the end of this study, the researchers say there's important clues here that could help us develop, and we're going to isolate the different bacteria and test them in animals, because we think there could be a pathway to creating a probiotic for anti-aging longevity within this cohort. Which is interesting, because that is something that the company that they work for already sells.
Oh my.
Already has claimed to be providing probiotics that reverse aging and prolong life. So
this study has several issues. I mean, the number one take home is, okay, maybe the aging, the cohorts, the youngest and oldest.
They have an completely unverified cohort of centenarians.
Right,
one.
Not verified.
They have conflicts of interest too. And it's published in a very shady sounding journal, Nature Aging. I don't know if this has very much prominence anywhere in the world, but
well, it's Nature.
It's Nature. I know.
And you can access this article for $39.95.
Yeah.
A bargain.
Yeah, what a deal.
It's
So-
if you add 6 monthly payments of $9.99, you'll get the supplements also.
Yeah. So it's one of these interesting. It's like I'm not trying to bash on Chinese research, but there's certain areas where research meets
Culture
propaganda.
and propaganda. Yeah.
And the propaganda is that people of this region live to an exceptionally long age. You also can't really. This is why there's a tremendous amount of artifacts found for early hominins throughout China. But the reason we probably don't hear a lot of them reported is because the propaganda that goes with all of the anthropology in China is that the Chinese people are separate people that evolved separately from the rest of us. And that this is the evidence. And that's why we don't probably hear a whole lot about the anthropology coming out of China, is because it has to get through the state filter. And so this is another situation, I think, where there's a filter. Otherwise, or, I mean, I could be totally wrong, and the oldest person on the planet wandered into a study on aging, and nobody mentioned it.
Nobody. There are a lot of people in China. I mean, probability-wise,
it should be China that has the oldest people. Right.
But
Well,
if
it
it's
could be
not
that
verified,
they just think about it because it's not verifiable.
well, but they listed it.
Can
And-
you really go and make an entire side point of your study about how you have the oldest person in the world if you have no proof?
right.
Well, and can you claim that you're studying 200 and something centenarians when you cannot
don't really
verify their
know.
age at all?
Right.
Yeah, and how do you differentiate them from younger age groups? From so are your age groups accurate at all?
Anybody over
And that's
72 years old, and there's two cohorts there that they are two cohorts. There's two groupings of age above that before they got to centenarian that they cannot verify age. And there's plenty of places in the
age.
world.
Yeah.
The oldest woman in
sure.
the world right now, I think she's in California. She was born in San Francisco in the early 1900s, where there were records kept. There's people born in France, England, Sweden. You can go back to the 1800s for some of these folks easily, and have perfectly good government kept records of birth. This rural farming community in China is not on that list, but will be in about 26 years.
Yeah.
23 years, is that right? But until then, 26 years. In 26 years, we can begin to identify centenarians from this region, but not before.
But not before. And in the meantime, just take the probiotics you've got and don't necessarily trust the company company funded study that probably finds a thing. And
So this is I know I'm taking too much time with the story, but this is also going to be a problem because as much as like Blair, you've been talking about, I want to have my microbiome diagnosed. Do you remember Merck and osteopenia?
Mm-hmm. Yes.
Where
Made a
Merck
whole
created
new
a
category.
bone
Yeah.
detection device that created a non-osteoporosis diagnosis that recommended a drug that Merck made.
Yes.
This is this funnel that this study here
study's
reminded me of, where you are diagnosing based on a definition of, in this case, evenness study, and have a machine that can tell people this is what you've got, and also provides the solution. There's a problem with that, and there's not any regulation that I've seen yet, because probiotics seems to be falling into the supplement category.
Absolutely. At
Which
this
is
point
incredibly
in time.
dangerous, seeing as how the gut microbiome we now know can affect so many things in human health and cognition, and the
your
connections
brain,
are everywhere.
Mm-hmm.
That food is regulated, but a transfer of microbiome is not.
And I do wonder about the diets of the young people that they included in this study. I mean, if they're like the typical college student, I mean, it's a different diet entirely in China, of course, but in the United States, it's usually going to be some form of cheap junk food, which isn't necessarily going to lead to a very healthy microbiome. So, I don't know if you really do want the microbiome of a young person This is a good question to be asking. Is it the microbiome or is it the diet? We know it's a combination of the two.
Or should there be another look at this study?
There should be differently.
Or should there be
replication?
A replication,
Replication.
somewhere else of this study before anybody follows anything that was produced by it? Maybe. I don't know.
Blair, would you listen to your kids? Would you listen to your kids if they were telling you how to treat a robot?
I think that you should. I love the story that came out this week from Duke University, where they interviewed 4 to 11-year-olds about Alexa and Roomba. They recruited 127 children. They were visiting a science museum at the time, and they watched a 20-second clip of Alexa and a 20-second clip of the Roomba. Then they were asked questions about the device. They found that neither Roomba nor Alexa deserved to be yelled at or harmed. But those feelings dwindled as they got older, which is interesting. They also recognized that Alexa was more human-like than Roomba, and they were more likely to kind of prescribe emotions to Alexa than they were to Roomba. So it was definitely related to the fact that she talks, of course. They decided that both Alexa and Roomba probably aren't ticklish, probably wouldn't feel pain if they got pinched. They probably can't feel physical sensations like people do, but they gave Alexa, as opposed to Roomba, high marks for mental and emotional capabilities, like being able to think or getting upset if someone was mean to it. So the part where this kind of starts to fall apart a little bit is that in the study, one 10-year-old said it was not okay to yell at technology because, quote, the microphone sensors might break if you yell too loudly. Whereas another 10-year-old
logical?
said
I like that. I like a nice logical approach.
Yes. Another 10-year-old said it was not okay because, quote, the robot will feel really sad. So this is the other question is it that you shouldn't hit or be mean to these things because they're property and it'd be morally wrong because it might break as somebody's property? Or is it because they deserve fair treatment? So I think more study is required, but ultimately there seemed to be a parallel between children's understanding that they shouldn't hit each other, shouldn't hit other people, and you shouldn't hit Roomba or Alexa. So this is an important question as we explore the world of AI, as machines get more and more agency, I will say.
Yeah.
And the question is then, beyond what children think are appropriate, knowing what might be in our future, as adults, should we model good behavior in the way that we talk to Siri or ChatGPT or the Roomba or Alexa?
I think so, but I'm terrified that it's going to be learning from the masses.
Right.
Yes.
So that's the other question is like, sure, these things aren't going to respond in a particular way because of how you treat them now. But as we learn more and more about these AIs and safeguards are kind of hopefully carefully being removed, they're showing some preference, some of these chatbots. And as preference develops, do personalities develop? Do these things happen where, it matters how you treat this technology? And are toddlers and young children kind of ahead of the game with us on this one? Are we going to get left in the dust where the AI will take care of us because we're rude to them?
And is it both at the same time? Yes, we can always model good behavior.
Yes.
We can always be what, a model of what we want to see our children doing in the world, right? But they're going to be getting information and modeling from others in their environment as well. So you're not the only one unless you're all alone having your baby in a house by yourself with nobody else and no internet or anything ever. There are other influences on your children that you can't control. But then additionally, there's the fine line of also teaching your children that, hey, this is the Roomba moves, but it's a robot. The Alexa is might be talking to you, but it's a computer program that's figuring out the best answer to tell you.
Right. And is it especially important to draw that line because children should not inherently trust AI, at least right now, because the truthfulness issue is still a huge problem, right? So like, and AI still also doesn't have morality safeguards where like they might suggest a bad thing to somebody. So there's all sorts of concerns there.
I think the toddlers are aware of it. If you listen to their answers, what they said, the dark side of this is that they believe that the AI or whatever, the robot, can have its feelings hurt and that it cannot feel pain. Right. And what is a more frightening thing that you can conceive of something that's angry with you and cannot be hurt?
Oh, yeah, that's no good.
No.
So the other thing I was thinking about with this too is like, as we continue, especially with chatbots on the scene, will there be a time at which you're not 100% sure if you're talking to or typing to or interacting with a human or an AI? You won't know the difference. And so you have to treat all of those things like you are talking to a human because you don't know.
I already do that. I'm like, I don't know.
I'm talking to this live chat on Chewy where I buy my dog's dog food and I need to make sure that I'm friendly and nice and I ask how their day is because they could be an AI or they could be a human. I don't know.
And, you always want to err on the side of caution, world robot domination and all. Be nice to the future overlords. But at the same time, teach your children how to stand up and talk back to them.
Yes. Oh my goodness. What will tomorrow bring? I don't even know. But the kids seem to get it. That's
the kids are getting it. The kids are smarter than everybody thinks. So what will tomorrow bring? Well, this month brings new fancy glasses for people who potentially want to just have the glasses read their lips. These fancy glasses are AI equipped, and they are also equipped with what they're calling echo speech. And these glasses, they've gotten off-the-shelf eyeglasses for this experiment out of Cornell's Sci-Fi Lab, Smart Computer Interfaces for Future Interactions. I love the name of their lab, the Sci-Fi Lab. They have trained an AI, a very simple artificial intelligence algorithm, to use sonar that is emitted by little microphones on the eyeglasses to then record the reflections of that sound in microphones that are also in the glasses, and use the sonar technique to be able to determine how your face is moving, to read your lips so that you can just wear a pair of eyeglasses and be able to send a text, do simple computer commands. They've so far trained it up in some 30 or so commands that the eyeglasses can read. So in the future, if you see somebody moving their lips and no sound coming out, what they are doing is silent speaking for their echo speech glasses that are powered by sonar.
That is interesting and bizarre. This is not where I thought this was going. I thought it was actually going to go in a different direction, which I suppose is the next logical step and may already be doable, which is if you had glasses that could read lips and would tell you what people were saying as you looked at them.
Right. So that's another potential future, right? Being able to determine the facial movements of other people. These are currently, you train it. So you go through the training commands and train the AI.
And it's using sonar of your face.
Sonar of your face. Yeah.
To translate. That's amazing.
Yeah. Yeah. So they've used, this lab has come up with a bunch of different designs. They've got some wearable earbuds that do another acoustic sensing technique that also tracks facial movements. They've made like a necklace, a pendant that uses infrared, and they also trained it up to do sonar as well, so that you'd have a necklace looking with the pendant looking up at your face and using the movements of your face to again command another device. And originally, when they'd started this whole line of engineering technology development, they were looking at cameras, but they determined that cameras use too much battery power. And also, there's a lot of data involved. And so, if you want to protect your privacy without having to send your data up to the cloud to be analyzed by an algorithm, these devices, the battery life on the eyeglasses lasts almost an entire day. And additionally, it can be connected wirelessly to your smartphone, and the smartphone does all the processing. The is an app that the AI is an app that runs on your phone and can help you interact with your phone or with a computer or with other devices. And
But the thing is, it's such a specific need. I'm trying to like place where this over.
Yeah.
No, I mean, the only thing I could think of so far was wanting to take a note in a class without making sound or texting on your device, because that seems like that's just like.
Instead, you're just copying what somebody else has said after they say it without actually saying the things they said out loud and with your lips. Yeah.
And then do people make a sub vocal sound while they're doing it, like?
So I'm sure people do make a sub vocalizing sound as well, and so that's another question: is why not just use sub vocalizations to be able to use these commands?
It's clever. It's very clever. I just don't know.
Yeah, I mean, the idea for who it would be for is this could potentially be the kind of technology that would help people who, can't produce speech. Maybe there's
or text.
Whatever, or text. Maybe there is some reason that they need to be silent, and subvocalization would be picked up for some. I don't know. Some specific examples that they brought up were very simple ones, such as you wanting to send a message to a waitress in a crowded cafe or restaurant, or maybe you're wanting to send a text to your friend, but it's very loud, so you can't actually have a conversation, but so you can face to speech text.
You can text them.
This sounds like James Bond stuff to me.
It is James Bond stuff. It's gonna be great.
That's what it sounds. That's the best application, as I can see it. Spy stuff.
Yeah. So anyway, yeah.
Well, this will be helpful, at least for any of us who get accidentally frozen and then thought out into the future, and then take public transit and see a bunch of people mouthing things. We'll understand what's really going on.
The future is just going to get weirder socially, people. I mean, it was weird at first when people were walking down the street talking to themselves.
Oh, jitter jatter, jibber jabber everywhere.
Now they're going to be talking to themselves, but not making any sound while they do it. It's going to be.
Well, because then this was the mediary step, right? This is when the people got the earbuds. Then it just seemed like there was crazy people also talking to each themselves, because they didn't have the phone, so you didn't know that they were in a conversation with somebody. So you always had to is that somebody talking to themselves, or is that somebody who's on the phone? And then people started texting, and the silence. Oh, the silence that fell over the earth.
Except for those people who have like their sound on and the responsive texting, so it's.
Yeah, I think that used to be a default, right? I don't think it is anymore. Yeah. That's
so anyway,
another iterative stage.
Be nice to Alexa and Roomba, and also the future is going to be full of sonar glasses that read your face. Fun stuff, everybody. This is This Week in Science. We hope that you are enjoying the show. And if you are enjoying the show, please tell a friend about it today. If you're really enjoying the show, please head over to our website, TWIS.org, and click on the Patreon link. Patreon is how we fund the show. We are listener supported. So listeners, viewers like you can help us maintain TWIS and keep on going every week, bringing you a new episode. You head over to Patreon, click on that link at TWIS.org, and join our little community there. Choose your amount of support. $10 and more per month. We read your name at the end of the show. $15 and more per month. You get stickers. Woo! There's other fun prizes as well. Yay! Join the club. Be a part of keeping TWIS in your ears and in front of your faces. We thank you for your support. We really can't do this without you. All right. Time to come on back to this last part of the show. We're going to start off this segment with what the whole show was last week. Blair's Animal Corner.
With Blair. She loves our creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
Oh man, I have a special Blair's Animal Corner edition of We Needed a Study for That? Here we go. Turns out a study published this week reveals that tigers have individual personalities.
They've got personality. Personality. Why was it just now? Fat what?
Mm-hmm. So there's the kind of the press coverage of the story. There's the actual story. But
Okay.
on the whole, it does seem like the point of this study was to see if there are personality trait differences in individual tigers and how that impacts their survivability.
Oh, okay.
As someone who has worked with wild animals of many kinds, from like fish all the way to monkeys and apes, animals have personalities. In fact, we have had studies on the show about things like fish and how their personalities impact the kind of the social ecology of the group and all sorts of things. So
Spiders have personalities.
yes, spiders have individual personalities. So
Mm-hmm.
all that aside, so this study, the point of it was really they wanted to know if the differences in tiger personalities, are there evidences of personality dimensions, something analogous to what's called the Big Five in human personality research, which I had to look up. I wasn't super up to date on this, but it's followed by the acronym OCEAN: openness, conscientiousness, extroversion, agreeableness, and neuroticism. So they are used for you to kind of understand yourself. And researchers found that there's a science to human personality, regardless of gender, age, nationality, whatever. It's all made out of these 5 basic traits. And so you can take a quiz and figure out your score in each of these areas and how that kind of impacts you and all this stuff. It's very analogous to sounding to me like the Myers-Briggs stuff and, you know, all the different kind of personality tests you can take to understand yourself. But basically they wanted to see if there were dimensions that they could measure in tigers that they could then associate with measurable outcomes like group status, health, mating frequency, all this kind of stuff. So we don't need a study to know that tigers have personality traits and that impacts them. I'm going to say that. But what they wanted to do, and they ended up doing, was measuring things well enough to be able to identify specific personality traits and how those impact tigers. So that potentially has value. Okay. So
did they come up with any take homes related to?
Yeah, and this is like the other weird asterisk I have on this study is the way that they did it is they looked at 248 Siberian tigers or Amur tigers. But the way that they tested them was through a personality test on their caregivers. So it was a questionnaire with a list of 70 personality indicators filled out by veterinarians, feeders, and other caretakers who work with tigers in the semi-captive space in China. And so the kind of the other weird asterisk on this is that I will also say, as an animal caretaker, it is very easy to project personality traits onto your animals as well. So it's not as clear of a measurement as kind of deciding parameters, watching videos, scoring things on a scale, right? So doing a kind of a squishy personality test questionnaire about tigers filled out by a person who feeds them we could do better, but we'll start here. And so what they found was that all the tigers displayed characteristics that separated them out into two overarching personality categories: majesty and steadiness. And so tigers that scored high for majesty were healthier. They preyed more on live animals. They ate and mated more. They were also regarded by human raiders as having higher group status among tigers. So they were very regal, demanding, got what they needed. But steady tigers were collaborative. They were gentler. They were more sincere, severe eye roll, if you can't see me right now, and more loving.
Sincere tiger. Yeah. This tiger sincerely wants to eat you.
Yeah. So these traits showed a role for up to 2 or 3 years. They could measure kind of the trajectory of this individual based on whether they were steady or whether they were majestic. And so there were benefits to both. There were kind of different ways that this would influence their dynamics in the areas. But ultimately, the idea is if you can understand different personality traits and categorize them, you can improve animal welfare and conservation. So, of course, in captivity, you can take better care of an animal if you understand their personality. But also, I think a good animal caretaker is doing that inherently anyway. The conservation side of things is if you understand the social dynamics of a species in a space, you can understand how much space they need, who is likely to win in a fight over territory, who's going to be the likely dominant breeder in a space, and how will that impact genetics. So there's lots of things that can come out of knowing personalities and how those personalities impact a species. But there's like I said, there's a lot about this story that I think could use some help. And I think that from a baseline saying that tigers have personality traits that impact their evolutionary success, duh.
Can we put that chart back up there? Is that possible?
Oh yeah, give me a moment.
There's a picture of a tiger.
Yes,
I have a picture.
That looks like a tiger doing a Flehmen face, also, which is a mating response. So that's very funny to me, but that they chose that. I think somebody who picked it was just like, "This is cute." Actually, that tiger, I think, just licked pee, but that's fun.
I mean, that could be cute too.
Yeah,
baby. Yeah.
Measuring hormones.
So something in that measurement did catch my eye, which is that it would have been possible for a tiger to have been identified on the majesty factor as a stupid tiger.
Right.
Yes.
And on the other side, the steadiness, they could have been identified as mysterious.
Yes.
What?
Less
yes,
mysterious.
You're correct. This is the problem. This is such a squishy,
gregarious, respectful tiger.
So
also, like,
are
they like that because of the other conspecifics in the space with them? And might they act differently if there were other individuals around? Do they not like that caretaker? And so they seem aggressive near that caretaker. So that caretaker has it is.
And
right.
how is adaptive on majesty below savage and imposing, and yet above excellent and positive? And how do you differentiate between excellent and positive? There's definitely something lost in the translation.
Positive or negative. Yeah.
A lot.
Yeah, I don't know, man. This study is a bit much, but I just wanted to throw it out there since I know it's making the rounds on the internet, and I wanted to kind of talk through some of it. But what I'm really excited to talk about this week is wet bird feathers. Okay,
Ooh.
so this is coming out of Johns Hopkins University. And this is one of those really cool studies looking at natural form and function through evolution and saying, wow, this is really cool. How does it work and how can we use it? And so this is looking at the sand grouse, which is a desert dwelling bird from Africa. They nest about 20 miles from watering holes because watering holes are where all the predators go to drink. And so they have to stay kind of far away so that they don't get eaten. And when they have chicks, the adult males will fly to the watering hole. I love this. They will gather water in their kind of breast feathers. They just kind of like
a sponge?
Yes, they sponge up water in their breast feathers, and then they fly home with it. They gain about 15% of their body weight in water, and then they keep most of it during the 40-mile-an-hour flight home. That takes about a half an hour. And then when they get home, they the chicks can drink water from their chest. So wow. This is a crazy thing that happens. Kiki is sharing a video right now. If you're listening to the podcast, I suggest you check out our show notes and look at this video because it shows how not only are these feathers extra absorptive, like they suck up water like nothing else, but they hold on to it with amazing efficiency. So from an engineering perspective, everyone's like, how does this work?
Yeah.
So what they did, so they used high resolution microscopes, 3D technology. They used scanning electron microscopy, microcomputed tomography, light microscopy, and 3D videography. They looked at the shafts. The shafts are a fraction of the width of a human hair. And then the barbules, which are the individual little things coming off the feather shafts, are even tinier than that. And so they're extremely delicate. And then they had to kind of dunk these feathers in water and film it with all these different techniques to try to figure out what's going on. They bend very specifically. They form protective tent-like clusters, and tubular structures actually in each barbule capture the water. They like put a lid on it to hold it there.
And I'm sure there's some aspect of surface tension that's involved as well. So the feathers, they wrap around, and as they're doing that, they basically hold a drop of water in and create something of a straw.
Yes. Yeah, no, absolutely. So it kind of has the sucking, and then it also has the holding onto it. It doesn't come off. And so
how does it hold on to it?
Yeah. They first kind of discovered these feathers over 50 years ago, but didn't have the technology to look at it so up close to be able to try to mimic it in real life. Cool. And so this is kind of the first attempt to demonstrate how the feathers work, really capture it, and then make computational models of the water intake, all so that they could figure out how the controlled absorption, secure retention, and easy release of liquid is possible through these feathers.
So this is going to be the next ShamWow.
Right. Yeah, I'm waiting for the
there's
the
so
sand
many ways
grouse
to use this.
kitchen commercial.
Yeah. So of course absolutely the ShamWow. If we want to talk real life changer stuff, netting for collecting and retaining water from fog or dew in deserts or places that don't have a lot of fresh water could be really helpful for that. The other one that they talked about a bunch in this study was about a water bottle design to prevent swinging and sloshing of water, because the idea is you could have like a sports backpack, like a Camelback or something. And then if the feather-like system was internal, that would keep the water from swigging around while you move with it.
That sounds like single use.
Yeah. Well, this also sounds like, it would harbor bacteria like nothing else, right?
Yeah.
But I feel like some of the lead researchers on this do a lot of long-haul hiking or running with hydration packs, because this is such a very specific request. I don't like when my water sloshes.
Slosh.
Yes. But the other thing that they brought up that I thought was really interesting is medical swabs. So if any of you have ever taken an at-home COVID test, which I'm guessing pretty much everyone has at this point, you have to swab your nose, and you dip it in a thing, and then you have to try to squeeze all of it out, right? And so the retention and then easy release of water is something that medical swabs are not very good at doing. So this could create a better medical swab, efficiently soaking up liquid and easily releasing it. And so the next step for this team is to print 3D structures to try to mimic this, to see if they can actually replicate it with a 3D printed version. So I hope it works. It seems like they have all the information they need, hopefully. I can't wait to see how this all gets used. But I also just love that I didn't know about the sand grouse, which is like the only bird that we know that does this crazy thing to be able to give their chicks water. I love it.
And you know that it is specifically adaptive because the stronger males, more capable of flying home with more water, are going to be able to give water to their children better, and their offspring will survive better. And so that's, this is something that was selected for.
Yes, absolutely. Oh, my
Absolutely
feathers are no
selected
good.
for.
I lost a bunch of water. Now my chicks are going to go thirsty.
Right.
The chicks won't survive.
3D printing, huh? I wonder if they'll be able to do the fine barbules and be able to, if it would be better to 3D print or find a material that assembles this way naturally.
I imagine it's a very expensive, very finely tuned 3D printer. It's not one you got in your garage.
My 3D printer could not do this. Yeah.
No. It's smaller than a piece of hair, but we'll see.
Sloshy water bottles.
We're gonna make sand grouse feather like materials using spider silk.
Yes, there we go.
There.
And spiders.
And then we'll finally have the world's best baby drooly bib.
Ooh.
It's true. Yes.
That's a good one.
That's a good one. I just am now imagining, though, Blair's water bottle just being inhabited by spiders because that's what keeps the water from sloshing.
No, thank you.
I know. Well, thank you for these fun stories.
Yeah.
Tigers and wet birds. Who knew that we would be so excited by it? Justin, what do you have for us?
Are there still more stories? Oh gosh. Okay.
More to go.
This is
Let's do it.
Oh, actually, we have to take a break. This is urgent alert. Attention. Incoming friendly reminder message from the folks here at This Week in Science. Eat your broccoli.
Okay.
That is all.
Oh, I had broccoli today.
Then you just ate a superfood. Yes. Congratulations. Researchers at Penn State found that broccoli contains certain molecules that bind to a receptor within mice. It's good. This is a reason we study mice. That help protect the lining of the small intestines. This is quoting Gary Purdue, agricultural sciences at Penn State. We all know that broccoli is good for us, but why? What happens in the body when we eat broccoli? Our research is helping to uncover the mechanism of how broccoli and other foods benefit health in mice and likely humans as well. It provides strong evidence that cruciferous vegetables such as broccoli, cabbage, and Brussels sprouts should be part of a normal healthy diet. So,
is it just the vitamins? I feel like that's we already know about this. Like there's vitamins, there's iron, there's fiber.
It's more.
There's more to the story. So this is, it has a molecule called aryl hydrocarbon receptor ligands that binds to hydrocarbon receptors, which is a type of protein called a transcription factor. This binding, they found, initiates a variety of activities that affect the function of intestinal cells. So this has to do with how much moisture passes through from the gut into the body. So basically just eat your broccoli. But they did test this in mice, and they found in a diet containing 15% broccoli, which for humans would be 3.5 cups of broccoli a day?
That's
It's
a lot of
going-
broccoli.
Seems like it's
Maybe
going
we
a
can
little
watch
hard.
Broccoli.
Maybe
It's
we
not
could.
that much too much, but it's a little.
That's a lot. That's a whole meal of
Every
broccoli.
day?
Over a day, so you can break it up. Half a cup of broccoli in the morning, then half a cup of broccoli for brunch.
Broccoli for
Then half
breakfast.
a cup of broccoli. Oh, we're not even halfway there yet.
Broccoli every
What?
day. I don't know.
I think there are other foods in addition to broccoli that could be eaten in this
Yeah,
way.
but Brussels sprouts. So you've got to fry those for them to basically have any decent flavor.
And
to
then
them.
you're
Maybe.
negating it by
Yeah.
frying it. Yeah.
But so the point this is an overfeeding of broccoli,
It's
but
for
it's
mice
because
also.
this is how you highlight effects
Yes.
in an animal model. And they found that compared to the group that didn't get broccoli, the part that ate their version of 3.5 cups of broccoli per day, 15% of their diet in broccoli a day, were much healthier mice. They had altered intestinal barrier functions, reduced transit time of food in the small intestines, decreased number of globulate cells and protective mucus, and decreased penneth cells and lymphosome production in the ones that didn't get it. So,
Eat your broccoli, kids.
eat your broccoli, everybody. Okay.
And just like Dana Carvey used to do, make sure you're chopping broccoli.
Nobody's good.
Chopping
That's a
broccoli.
reference. That's a reference from
know. So long ago.
30, 40 years ago.
Long ago. Shush, shush. Okay, next story. Hush.
An analysis of strands of human hair from a burial site in Menorca, Spain, indicates that ancient humans used hallucinogenic drugs derived from plants. These findings are the first direct evidence of ancient drug use in Europe, which don't say ritualistic use. Don't say ritualistic use. Don't say ritualistic
What are they
use.
going to say?
May have been used as part of ritualistic ceremonies.
Great.
It's like they can't help themselves. It's like previous evidence of prehistoric drug use in Europe has been based on indirect evidence, such as the detection of opium alkaloids in Bronze Age containers, and the findings of some drug plants in ritualistic contexts, and the appearance of drug plants in artistic depictions. Hey, I'm throwing a ritualistic context this weekend, and I want to invite you. Oh, you can make it? Oh, that's great. Hey, my artistic depiction device is on the fritz. Would you mind bringing some cave paint? Oh, okay, I'll see you around sundown.
Why is it that when we find out that ancient people used drugs, it has to be for a reason?
It must be that this anthropologists never get invited to parties. This is the only thing that I can they have such a we talked about this previously. There was a study that these little owl depictions that were found all throughout Europe and all these different sites were ritualistic burial tributes, is what they had been called for it. And then at some point we figured out these are likely kids' toys made by children that they played with, But for the longest time, these are ritualistic, ceremonial, like everything. And it doesn't matter where in the world you are. It does not matter where in the world you are.
Maybe it's for as long as we have our written, Western human history. The special drugs have been monitored and only been in use by the religious hierarchy, the top of the religious hierarchy, for ritualistic religious use. I mean, this is
when.
I know, but this is the story.
In our recorded history, what religion is there where there's priests and shamans and they're the only ones doing the drugs? Like this is not how any of it ever has worked.
Only
There
the
are
precious few.
There are traditions that use drugs in a
Ritualistic way.
ceremonial way, but that's in the current day and age where they're revisiting things that people used to do. And if it wasn't under that, by the way, for some of those, The only way they're allowed to continue those practices in the modern world is by calling them ceremonial rituals. Otherwise, it would be forbidden from doing so. So anyway, this is researchers examined the strands of hair from a cave in Minorca, which was first occupied about 3,600 years ago. So it was kind of interesting, and it was contained.
5 centimeters.
There was a chamber of the cave that was used as funeral space until around 2,800 years ago. Previous research suggested about 210 individuals were interred in the chamber. However, strands of hair only from certain individuals were dyed red, placed in a wooden horn container, and decorated with concentric circles, removed to a separate sealed chamber further back in the cave, and these hair strands dated to about 3,000 years ago.
Interesting.
Hey, wouldn't it be like wild if thousands of years from now somebody could look at our hair and figure out that we were high? Like they would use like, I don't know, like a special kind of water or something. I'm going to set some aside in this groovy container and like put it way in the back and dye it red so they know what to look at when they find it.
So this is why would you put a mat of over 5 centimeters of hair that you've dyed in a special carved container?
Time capsule.
A time capsule. Okay, fine. Yeah. I don't know.
Fada says it's an ancient salon.
Hair salon. Yeah. Oh, we have to test a little bit of the hair to make sure that the dye is going to take right and not, damage your hair too much.
The authors used ultra high performance liquid chromatography and high resolution mass spectroscopy to test for the presence of different alkaloids. They found them. They found a whole bunch. I won't list them. Definitely hallucinogenics from back in the oldie times. But this said, and the author suggests these drug plants may have been used as part of ritual ceremonies performed by a shaman, because no matter where in the world an anthropologist is studying party people of the past, they always, always, always imagine them the same way.
Shaman is code for drug dealer, right? I assume in this case. It's the person that came with the supply.
The sacred person.
Hey, are you heading to the ceremonial context this weekend? Yeah. Hey, do you mind if I hit up your shaman?
Yes.
Mine's like sort of out of the off the circuit at the moment.
He's on a pilgrimage,
Yeah, he's he's doing one of those on the shelf pilgrimages kind of things.
Yeah.
Oh goodness.
Well, I can't wait to find out, what future anthropologists will say, archaeologists will say about our various.
It's almost like a reverse anthropomorphization.
Right.
Well, that's what I was going to say. I didn't want to go on a whole thing, but there are animals that there are birds that eat fermented berries off the ground and get drunk. There are animals that essentially do drugs. They're not doing a spiritual ritual. It's just like, oh, this makes me feel funny. I'm going to do it again.
Yeah. Have you seen your cat roll around in catnip?
Yes.
Yes. Or there is evidence of birds and other animals using herbs and other plants found in the environment for keeping their houses clean, keeping the bugs
away.
To
knock it. Not that you can't do it this way, but assuming that that's what's going on in every incident.
Yeah.
No.
Yep. Yeah. Assumptions, huh?
Mm-hmm.
What do those do? Yeah. Well, not making assumptions, I just want to go very, very quickly through a couple of quick finds. Salk Research Institute scientists have just published their findings in the Frontiers in Aging Neuroscience. Their studies looking into the synaptic photons, the synapses. How do the synapses connect to each other, and what happens in aging to the synapses? Well, they have determined that there is a scaling law, and this is something that has been previously determined years ago, that the size of the synapse is related to the distance between one side of the synapse to the other. It is related to the size of the mitochondria that are in the synapse, in the cellular terminals that are coming together. The mitochondria need to be a certain size, putting out a certain amount of energy, and it all relates based on size. They, in this particular study, were able to show that this size law starts to fail as people get older. And whether it's just dysfunctioning mitochondria, that the mitochondria are failing, there's something that's happening at the synapse, at the point where our neural connections are being made that is causing dysfunction. And so they're, from this research, looking at directly focusing on the mitochondria, as we've talked about before, as one of the targets to maintain healthy aging and healthy synapses in the brain.
Yeah, and not just that, throughout the cellular body.
Throughout the whole person, yes.
Mitochondria is going to be the thing that they're talking about, is going to be mitochondrial transplantation. It's not going to, this is the only way. This is the only way we're going to get to this Blair living forever situation.
Yes.
Is because it's too late to genetically alter you, and we're only starting research that can do that through this workaround that we discovered 20 years after the research was halted for religious reasons. We're not going, it's too late to alter any of our genes or our children's genes to live forever. The closest thing that we're going to get is going to be mitochondrial transplantation.
Possibly, or if we can just figure out, if we don't transplant them, what are the signals? What are the molecules? What are the receptors? What are the things that we need to do? What are the bacteria that we need to have in our tummies to get all the metabolites and all the nutrients to make sure that our mitochondria stay healthy and stay fit and keep powering the cell?
And one of the things, the reason I say mitochondrial transplant, it doesn't mean that you take one out and put one in. There is a natural fusion thing that mitochondria do, where you put more mitochondria in, and they snap together and they go, oh, hey, part of you isn't working. Let me take over this.
Right.
Let me take over these duties. And
that's how they kind of came to be anyway. Right? Mitochondria were just this important organelle. They're captured bacteria, right?
Yeah.
Oh, this little part. I'll just do this for you. They'll help each other out.
They do. They're amazing at it. Anyway, that's a side tangent, but that's where I think the future of everything is mitochondria. That's the one thing that should be studied for every disease, for everything to do with aging, for every kind of cancer, for everything. It's all going to come down to healthy mitochondria.
So promoted from the powerhouse of the cell to the future of everything. Got it.
The powerhouse of the cell, but
it's not just the powerhouse.
But it's also the everything else. It's like a lot of the crucial proteins and it
has genetic information,
regulatory
RNA.
Right?
There's a whole bunch of
all of that is really dependent on a healthy functioning mitochondria, which has this amazing ability to heal with the introduction of healthy mitochondria.
Yeah. Well, these researchers, they were able to study the synapse using electron microscopy. They were able to visualize the components that were incorporated within the synapse to be able to see whether or not this scaling law, whether it could be violated in age or in disease. And really the researchers, the lead researcher, Reynolds, says, the images we have captured of synapses are snapshots of a dynamic process. With these snapshots in hand, we can begin to think first about the mechanisms that coordinate the expansion and contraction of the various parts of the synaptic complex, then ask how disruption of these mechanisms can explain age-related cognitive decline. This opens an entirely new way of thinking about cognitive decline that could lead to new targets for future therapeutics. So, mitochondria targeting and Yes, active, dynamic synapse complexes. How do we keep them healthy? And my final story for the night, I would like to talk about some wonderful researchers who have just published their work in Nature Methods. Their work at ICFO, this research institute, they are taking optogenetics to the next level. Like really, truly taking optogenetics to the next level. So we've talked about optogenetics previously as a way of controlling cellular function by incorporating light sensitive receptors into neurons or cells, and then being able to use light, like usually blue light, can also be red light, but usually blue light, that is able to trigger those light sensitive receptors to then cause some kind of action to take place. People have been talking about.
Is it blue light? One of them penetrates deeper into the brain. I can't remember.
I believe it's red. The red light goes deeper, but it's not as specific. Okay. Yeah. Anyway, they looked at this and they're like, that's interesting. Okay, so we've got electrical transmission, electrochemical transmission in neurons and synapses. We've got light transmission that's happening in the synapses. But why don't we put these together and we'll make neurons that emit light to trigger other neurons? So let's make light a neurotransmitter. Let's turn photons into neurotransmitters.
Wait, doesn't that just turn us into robots?
Sounds like it, yes. So this is the photon-assisted synaptic transmission system, and it is based on luciferase, which is found in luciferin, which is found in fireflies and is the light that can be emitted, and then also channel rhodopsins, which are the receptive light receptive molecules, proteins that are in our eyes. And so these luciferases and channel rhodopsins in different neurons were able to work together to create actual circuits in a living organism in C. elegans, the little worm, the lab model, the worm that could. They initially created these C. elegans worms with a nutritional deficit, so they didn't have a certain glutamate nutrient in their diet, and so the FAST system in the C. elegans led to they booped the worms on the noses to stimulate the neural sensory process, which is like a pain signal. Hey, boop! I boop your nose, worm. And so then the worms would want to move away from the nose boop, and they couldn't unless this particular system activated. And so they fixed the nutrient deficit by creating this system that worked, and they were able to so yeah. Yes, they were able to put different systems together, and I'm amazed by the whole concept of what they've done here. But yeah, according to the researchers, it's interesting to use light as a messenger because it could be used in other interesting ways to help understand underlying mechanisms of brain function and complex behaviors. Of course, it could lead to new treatments. I mean, I don't know. Do we want that? Could it help repair damaged brain surgeries without invasive surgeries?
It's a far way to go from C. elegans to human brains, but
so far.
Absolutely, that's what I first thought of, was just kind of repairing brain damage by replacing neurons with essentially fiber optics.
With it is like fiber optics, yeah. So, could you create a system where you're not a worm, where it actually would work to neuron to neuron light transmitted instead of chemicals.
Isn't that how Data's brain worked in Star Trek? He had a positronic brain, I remember. But whenever they opened up his head, there were always lots of lights flashing.
Yeah. Yeah, first thing we need to do to improve humanity is get rid of the brain.
Just what? No, don't get rid of the brain. We like the brain. The
Just
brain is a
enhance with
wonderful-
flashing lights, as you often do.
Look, I do not need my brain flashing like the computer next to me. This is
It's more like a rave, you know?
distracting enough. I know. Yes. Yeah. So anyway, researchers using light as neurotransmitters. And that's where they're going now, and it's very exciting. And I don't know, what are they going to do with it? That is the question.
And
Who
it's not called a
knows?
rave anymore,
It's
by the
not?
way.
Oh, it's a ritual.
Ritualistic context.
You're
is what
right.
It's now,
You're right.
what they now call it.
I'm sorry. 1,000 pardons.
Ritualistic music session? I don't know.
Ritualistic context session.
Session. Have we made it to the end of the show?
We've
I
done
think
it.
We may have.
I think we have made it as well. Thank you, everyone, for joining us for another episode of TWIS. We are so glad you've been here. I want to give a few shout outs to people who help with the show. Fada, definitely thank you for your help on social media and show notes. Really wonderful to get your help getting the word out about the show. Gord and Arenlore and others who are in the various chat rooms, thank you for being there and being friendly. To all the other chatters, thank you for being there too and for chatting with us. And we love it that you're here, and the YouTubes and the Twitches and the Facebooks, and you're here while we are, and we get to interact, even though we don't always interact with you. We're watching, we're paying attention. Additionally, Identity 4, thank you for recording the show. And Rachel, thank you so much for your work editing. And I would love to, of course, thank our Patreon sponsors. Thank you to Teresa Smith, James Schaefer, Richard Badge, Kent Northcote, Rick Loveman, Pierre Velazarb, George Chorus, John Radnaswamy, Carl Kornfeld, Karen Tozzi, Chris Wozniak, Dave Bunn, Vegard Shefstad, Hal Snyder, Donathan Styles, a.k.a. Don Stylo, Ali Coffin, Reagan, Don Mundus, Stephen Albaran, Daryl Myshak, Stu Pollock, Andrew Swanson, Fredis 104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles Jack, David E. Youngblood, Sean Clarence Lamb, John McKee, Greg Riley, Mark Hassenblow, Steve Leisman, Ken Hayes, Howard Tan, Christopher Rappin, Richard, Brendan Minish, Johnny Gridley, Remy Day, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Rick Ramos, Philip Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E. Oak, Adam Mishkon, Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Disney, David Simmerly, Patrick Pecoraro, and Tony Steele. Thank you for all of your support on Patreon. And if you would like to become a Patreon sponsor, head over to twist.org and click on that Patreon link. On next week's show,
We will be back Wednesday, 8 p.m. Pacific time, and again at 5 a.m. Central European time on Thursday. Broadcasting live from our YouTube and Facebook channels and from twist.org/live.
Want to listen to us as a podcast, perhaps as you fiddle with the positronic brain of your Android friend? Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, get your friends to subscribe as well.
For more information on anything you've heard here today, show notes, links to stories will be available on our website, www.twist.org, where you can also sign up for a newsletter.
You can also contact us directly. Email Kiki at Kirsten@thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twist.org. That's me. Just be sure to put TWIS, TWIS, in the subject line, or your email will actually get sent to a Roomba who's very angry at us and will never tell us about it.
Oh no. You can, I guess, still reach us via the Twitter, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you'd like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views. But I've done the calculations and I've got a plan. If you listen to the science, you may just understand.
Yo is the after show. Brian Williams wants to hear the hiccups. Hiccups? Yes, little baby hiccups.
Yes, I had a hiccup for a second a while
you?
ago. Yeah, and
Right,
I let one slip out, and then I muted, and I wondered if it made it on the show. I don't know if that's what they're referring to.
I don't know. We'll find these things
Or
out.
the baby, I think they were baby coughs, is what I heard. But
Sick babies and coughing, going, hell.
that's what I thought I heard.
How are things over there, Justin? Healthy? Happy?
Everybody is 100% on the road to being healthy.
Awesome. Good. It's good to be on the road.
100%,
Let's get there.
50%, all the time.
Yeah. So you had fun last week, Blair? You gonna
I
do
did. That was fun.
the takeover show? You're like, I'm gonna do this all the time.
When necessary is what I will say. It was a lot of talking. I was very tired, and my voice was very tired at the end. So
Yeah.
it was. I mean, I was very happy
An
Brian was there,
hour, right?
because
Yeah.
otherwise, talking all by yourself for an hour is, you've done it before, Kiki. It's tough. It's very tough.
Yeah.
So I was like, I need somebody to interact with, please. And he brought his own story, which was awesome. He did a little research before the show.
He's good like that. He's
good.
He's good like that. He knows how to make it make it good. He's like, yeah, I'll bring you one.
He's like, I've seen the show. I know what to do.
I think I've seen this one before.
Yeah.
One time.
Yes. You guys did miss, I think, my favorite story of the year so far, which was about T-Rex lips.
Oh, right. Had the lips. Did they have lips? They did have lips.
did.
They were smoochy.
I was like a
boochies.
little bit confused by that because I kind of was under the impression that they already did have lips, I guess. And every
Well,
depiction
you're
that I've
smarter
ever
than
seen-
most of the depictions. So the depictions all had the teeth out. But if you look at
Especially the big
the
teeth.
comparison they did in the study was Komodo dragons. If you look at Komodo dragons, their mouth's closed
What?
completely. So they have lips that
T-Rex.
cover their teeth.
Okay. For some
But,
reason,
yeah.
I thought that T-Rexes also already did that, but maybe I was.
This is going to be one of those kind of Berenstain Bears kinds of things. How many images of dinosaurs have you seen that did not show T-Rex with its teeth sticking out? And you're like, oh, of course. It does. I mean, whatever. And then you
Yeah,
look
of
and you're
course
like,
they have lips.
oh. No, it was all teeth. It's
Yeah.
all teeth all the time before.
Yeah, like it's here. Let me look.
I mean, especially if we're going just from, like
Look at all these.
skeletons. Yeah.
They got
You
their
start with
chompers out.
Yeah.
And so it's analogous to an alligator or crocodile. They have their chompers out. But
Okay. But these are also like Like, why show a T-Rex with its mouth closed? You know what I mean?
Well,
like,
so
when
like, look
everybody...
at this is a toy, but
They
like
had noses. They didn't run around with their mouth open all the time.
right.
Right.
So like, so they definitely could close their mouth, and so, but like I said, that it was like an alligator where you'd see the top teeth all the time.
Okay.
But
so
now,
so we would say that alligators don't have lips because you see their teeth.
correct. They don't have flexible lips that like cover, and they can like veer and they can cover. So they can't do that. So, but Komodo dragons can. So like,
So now I'm thinking of all these reptiles, like Bill the fireman,
so like
playing with their
Komodo
lips.
dragon. Here, I'm always afraid to just like Google anything on
Oh, yeah.
screen, you know?
No,
So
you can't
okay.
just Google things. But
so here, so now look at
You
the
can
Komodo
show us.
dragon. So if
Yeah.
you look at like this picture is a great one. So they have this kind of lip flap. They have like an extra row of scales almost that covers their teeth.
Mm-hmm.
Like, look at that guy. See? So T-Rex looked more like that.
Which is actually, this is how I've pictured it. And I guess it's a misnomer on my part, but which accidentally got correct. But I think I've always assumed that T-Rexes are shown like because
Right.
it's sort of like the sort of joke of the hunter shooting the bear while it was drinking water, and then the taxidermist puts it upright into a fierce position. It's like you show a T-Rex, you show it looking fierce because.
But like, look at this dignified gentleman. Just look at him.
Yeah.
Dignified.
Look at this guy. There he is. Just there you go. There's the difference.
Rawr. Lippy.
So I love it.
Put a little. It does make me think of T-Rexes in a different way, for sure. It does. I mean, you don't think of T-Rexes as potentially aggressive and dangerous. I mean, large, several-tonned creature, yes, definitely. But if they're not showing off those teeth front and center.
Mm-hmm.
Right. We have, let's see, Fada's going to sleep. Kevin, are you going to sleep? It's just 10 o'clock. And, next week, I will not be here again.
Oh,
yes. I'm going
Justin,
to
you gonna be here next week?
I hope so. Gosh, I hope that every week. Not even just for this show, just that I'm on the planet for another week.
Yes.
Okay. Well,
yeah, I should be. I don't
fine.
have anything.
I'll clumsily work the controls.
You do a great job.
You do it better. I feel like every time I'm like, and I don't see that look on your face when you're playing music, so I don't understand. My gosh,
it's
you're so
maybe
big.
Oh, where's Felix? Why does this? Why does it have that? I want to see it. I need to change
your T-Rex teeth, Felix?
Arr. T-Rex teeth. Arr. Arr. Show those T-Rex teeth off. Arr. I'm gonna turn. I have to move this.
Very good.
Arr. There you are. My screen. I like looking into the camera, but sometimes it makes it hard to see the peoples. Arr. Arr. Do you have big teeth, Felix?
Oh my gosh, so many chompers.
Yeah.
And he had them immediately.
That's fast.
He had a tooth per month. But, this came in right away. Like whatever the thing says is when teeth are supposed to come in. Like they should be getting their first teeth about all of them.
Nope, we already
Get
have
all
them.
of them.
All now. Aw. Almost 1 a.m. in Pennsylvania. Well, have a wonderful night, Kira. Thank you for joining us tonight.
And you said, Kiki, you're going to be at a conference next week?
I am going to be at a conference next week.
Nice.
Yeah, I'm excited. It'll hopefully be good. I'm not throwing this conference. I get to just attend the conference.
Hooray.
So I get to, maybe, actually interact with people a little bit more. We'll see. Humans. Humans. Who are these other beings that I have not interacted with for a very long time? Yeah. Got to meet some very wonderful humans actually this last week, and I'm super proud of the panel that we pulled off for Science Talk. We got a one of our board members used to work for NASA, and so he knew people from the James Webb Space Telescope's media team, and so we had a panel telling us the story of all the work that went in to get the word out about James Webb over the last 18 years. And so one of the women on the panel, Maggie, she's been on the James Webb media team, doing social media and website stuff since the very, very beginning. Everyone else kind of had come on at different stages, but they talked about all the things they had to do. Like they actually put a GoPro into the telescope as they were putting the telescope together, like in the clean room, so that they could get pictures of the assembly from the inside. And so like the telescope is probably out in space with a GoPro in it because once it was in there, they couldn't take it out.
Batteries are dead, but otherwise,
So the telescope didn't work, but we have a backup.
It's a GoPro.
It's not going to be quite the resolution that we were initially shooting for.
Let's see. Over here we have space, and over there that's space, and looks like over here. Oh, that's some other space. Excellent.
More space.
Good job, GoPro.
You really went. Yeah, but they were
awesome,
fantastic, and it was a really great panel, and it was technologically super cool because we had in-person people, we had video, so it was multimedia. We had people joining in from DC, Goddard, so like we had people all over. It was this crazy multimedia thing that we put together. So my team should get an Emmy, I think.
That's awesome.
I don't know if there's like awards for really cool panels that are produced at conferences.
Yeah.
I think my team deserves one.
Nice.
Yeah. It was fun. Good to see all the science communicators out. Mm-hmm. There are people out there doing some great work. It did bring back a little bit of faith in humanity and, the people that we have out there talking about things.
Yeah. Nice.
There was a lot of discussion about incorporating faith-based communities and figuring out like not just inclusion and diversity, but like, these code words that we're using these days, but actually how to put them into practice. But, yeah, I have faith. Anyway, I won't be here next week. I'll just send you stories. Yeah, JG, I know, 18 years. I mean, it was such a long time, just the Webb story. And it was the beginning of This Week in Science as a podcast that I think that the Webb was really starting to get going.
Wait.
We were definitely on the radio before. We were definitely on the radio before Webb, but happy Felix. Yeah. I think about 2000.
Oh, happy for right now, but he's playing with a drawer.
Oh,
These
well, he's
I
gonna
probably
smash
shouldn't
his fingers.
admit what a terrible parent I am. But I've gotten to the point where
He's gonna
I've
smash
told him
his
enough
fingers.
times, like,
You're
don't
gonna
play
smash
with
your fingers.
drawers. You're gonna get your fingers caught in there. And he has a few times, but it still does it. And so now I'm just kind of more like,
Well, there you go.
sometimes you just have to learn through experimentation.
You do.
And this might
Go,
be
little scientist. Go.
one of those.
Go experience. Go experiment.
But then he's gonna like lose a finger or something, right? This is the fear. And then you're like, oh, what a horribly.
It'll grow back. He's part starfish, right?
That's right. At this age, I think the fingertip at least might be.
You could sew it back on just yourself. That'd be totally fine. All right. Blair. Oh, Blair probably had to go to the bathroom. I was going to say.
I do. Are we just
You-
going to say goodnight?
Yeah, Justin has a child who's going to cut his fingers off
Okay.
in the drawers, and you have to go. Like, let's.
I have a fetus
Well,
stomping on my bladder, so
It's not the drawer. It's just that the meat slicer happens to be in the drawer that he's got
Got
open.
it.
So I
Okay,
should
cool.
probably.
So
say
do
good
it.
morning, Justin.
Good morning, Justin. Say goodnight, Blair.
Good night, Blair.
Good night, Kiki.
Good night, everyone. Thank you for joining us for another episode of This Week in Science. We hope that you'll come back again next week. And in the meantime, stay healthy, stay happy. Don't smack your fingers in a drawer or cut them off with a meat cleaver. And I'm going to end the broadcast. Stay curious.
Just put pressure on it.